Hi everyone, so in this video I want to introduce a new operation on a set or define a new type of set called the power set. So the power set of X we denote with P, this nice script P. So P of X is the power set of X. So inside of this goes a set and the power set of X is defined to be a set whose elements are all of the subsets of X. Okay, so this is quite an abstract idea. So let's think about some examples that hopefully will illustrate this idea. So let's first start with number 1, where we have a set that contains the elements 1, 2, and 3. So let's think about what are all of the subsets of A. So we would say that the set 1 is a subset of A, since every element in this set, which is just one of them, 1, happens to be an element of A. We would say the set 2 is also a subset of A, and the set 3 is a subset of A. Is this all of them? No, we have not listed all of the possible subsets. So we listed all of the sets that have just one element. We could have sets that have 2 elements that are subsets of A. So for example, 1, 2 is a subset, 1, 3 is a subset, and 2, 3 is a subset. So that takes care of all of the sets of 2 elements that would be a subset. And then we have one subset, which is all of the elements of A. So A is going to be a subset of itself. And let's think about it. Have we listed all of the subsets of A? We've forgotten one subset, and that is the empty set. The empty set is a subset of every single set. So any power set that you come up with should include the empty set, since the empty set, again, is a subset of every single set. So the power set for A, in this case, should contain 1, 2, 3, 4, 5, 6, 7, 8 different elements, okay? And now the elements of the objects in a power set are sets themselves. So the power set of A, therefore, would be, first of all, the empty set, and then we have all of these singletons, sets that involve just one element, and then we had some sets that involved 2 elements, and then we had one set that contained 3 elements, namely A itself. So this would be the power set for A, which contains, again, the empty set, these 3 singletons, these three subsets of 2 elements, and then the set itself. So that would be the power set for A. And so notice for any set A, such as this one, A is a subset of itself. So every power set is going to contain the original set. So let me just make this comment. For any set A, we have that A is a subset of itself. So A should be an element of the power set of A. That's always going to be the case. We're also going to have the empty set is going to be an element of the power set of A. So we should always have A itself and the empty set included in the power set of A. Okay, now let's think about what would the power set for the empty set be. So what are subsets of the empty set? And there's only one of them, which is the empty set itself. So the empty set has only one subset, which is the empty set itself, since any set is a subset of itself. Otherwise, the empty set has no other elements, so we're not going to get any other subsets. So therefore, we've got the power set of the empty set is going to be the set of just the empty set. And one thing to clarify here is that the empty set is not the same thing as the set containing the empty set. Since this set contains no elements, and this set contains one element. And similarly, we would say that the number 1 is not the same thing as the set containing 1. So this is a number, and this is a set. So these are considered different in general when you just consider the element itself compared to the set that contains that element. So just be careful about that notation. Okay, so that wraps up our discussion on power sets. You have a question on the quiz very similar to the first one over here. And to kind of recap what we talked about in the last class, to connect back to these ideas, if we want to prove that A is an element of some set, then we need to show that A satisfies statement P, so that P of A is a true statement. If we want to prove that A is a subset of B, then we need to prove that if X is in A, then X is in B. So it's a conditional statement that we want to prove. If we want to prove that the two sets are equal to each other, then we need to show that A is a subset of B, and in addition, B is a subset of A. So we will work on proofs of this variety in class next time.